Okay, so now we have something that is doing the RMS norm. And the RMS norm is being used a ton of places inside the transformer. And Gamma is using it more than Jax, it seems, but now we I think this is a good setup to just build the individual modules, and then hopefully we just, as I said in the last video, we just use as much as possible from the Gamma code base and try to stay very close except where we need it. But I still want as much as possible that we have full like numerical equivalency like here, where the output is like that. And this may have, of course, some disadvantages. There might be that Gamma has some optimizations or something, but this is another question. It's more useful to have something that agrees with the Huggingface implementation, I think, and then it's always possible to substitute in some optimizations if they exist. So now the next step will be part 7. And that will be the it will be the Qwen3 projections. Okay, so we have in Qwen and Gemma this grouped Curie attention where we have a specific number of Curie heads that are linear transformations. So we're taking the linear transformations of this RMS normed inputs, and we want to ensure that this will work out well. Let me just think if I should try to debug and see in there what is happening, or if I should go in directly. So we are here where we just did no, we are here down in the call. We did a input normalized, and this normalized is going into the attention, and the attention is up here, and the attention is taking this thing and somehow not doing the, I could not get it to work with the breakpoints. Should just try one more time. This is part 5. So we need to say Qwen3 modeling here, and we are going to say that after the input we are just we are layer norming it, and then we're doing the self-attention, and in the self-attention we are applying this one immediately. So that means if I want now to take a self-attention module, it's literally just this part. It's just this part, or this part. Oh. Module object is not callable. For some reason it is not used. Shape, query prior use, shape. What is the problem here? This one. This is not a shape, apparently. Or something. No, I don't understand. It's this one. S Now I know. Okay. It's here. So I'm getting a bit confused. It's because I do not know if I should just copy this entire thing. That just seems a bit stupid. Like, we have so much good stuff here. And most likely there will be some problem somewhere So where do we think the problems will be? There will be problems. There will probably be problems everywhere. Numerical problems, I mean. For some reason it's Fury projection 0 to 6. Okay, I will start by importing this attention module, and I'll just fill in all these things, and I will see how close we get or something. So the way that I'm going to do that is I'm going to go up here, and then I'm going to say import gamma as gm, like this. Was it like that? From gamma import gm. And then I have from gamma modules dot attention. Is this a thing? No. GM dot modules. No. Okay, let's try to be a bit smarter about it then. Modules has an init. And init is not here. This is it. Okay, great. There we go. So that is it. And we are saying attention is equal to gamma.modules.attention. And we have a specific number of heads and everything. And this will be this thing that we have up here. So we're going to import that. Import from import that, no, part 3 Qwen3 state, and then we are going to use that for all the parameters. What are they? They are here. So let's see. Do I to do this all again. So this is the Mercury heads. Attention type, I do not know which attention type it is. It is the global one, I guess. Does it have a default? It did not have a default. Attention type. Global. Global. No, we can do something like give it a modules dot attention type. Wasn't it here? Whoa, what is this? I don't want this. It is here in modules. It's because it's not C# or something. Global 1. Okay, maybe like this. So it's just something with intelligence or something. Okay. Qwen3 pre-attention scalar. Pre-attention scalar. You multiply it onto the thing before you do any rope or anything, but rope is applied after the rope. So let's just set that to 1 for now. And rope base frequency, do we have those? This is rope theta. the scaling factor? Scaling is none. Let's set it to none now. We'll probably throw some error because of that. And then attention loaded soft cap. We do not have that in Qwen, I believe. None. And we do not have any sliding window. We have full attention. And then we have use norm. Normalization. That we will see. For now we'll have false. Okay, and then a bunch of commas. Up here too. Perhaps you forgot. There. And then we have some colons. Okay. Great. And then what are we gonna do? We are going to make now some kind of parameters object, and we already have it. So we are gonna load it, and it is from here. Parameters dict. This one. So params dict. And then import tree scope. And we are then going to go in here in layer 0. So we say layer 0. And then into the attention. These. We believe that these are the parameters for the attention 0 params. And then we will see if we can do attention.apply. And we will then apply it with a dictionary that is like this. And then we will have a call here that segment position. Input absolute positions of shape. So that would be batch.arange. This would be the batch size. This can be ones for now. Segment position. Because I do not care, like once we get down to the rope, the positional embeddings, we have to know something about the positions, but for now we can avoid it. And this input sequence will just be BTD. So we will have our X being, was it called X? Yeah. This will be this will be b to t is equal to this thing. And t be equal to 4. And then, so I'm just making a random input with the right dimensionality to this thing, and I then want to say import a key, some kind of key, and then I will say key x. I did not import checks. I will have to make some key that can be a random number generator key, and then I make the x as jack.random.normal with my key for doing that and some shape, and it will be bdt. And then I will also have a segment position that will just be jax.ones, and this will be .as type bfloat jnp.bfloat16, and this will be jax.ones of shape. It will be b.times t, and it will just be ones, and then it says no, we do not have this. Does Jax have it? No. Bload, yeah, bfloat jnp. Ones, jnp.ones. Okay, and then I will give it x and segment position and none and none. And we're going now to this thing. Q rejection self.qeinsum. And we're going down into the einsum, that's good. And we say, oh, it says 4. So maybe we did the wrong shape. Batch, sequence length, and then embedding them. BTD, and then there's some entering b quit. Okay, that's fine. Then I'll just disable this, I think. I wonder if I need some kind of thing that makes the updates being triggered. Yes, I do. So what is it? This thing. Because what will then happen when I do that is that hopefully I can edit directly in the Gamma code. I hope. Is there another one? No. That's good. Now I get an error. So, hey, for some reason, blah blah. Curie projection is this, and I will just now return it because I care about this thing. I care about this thing that I care. The goal of the entire this part is to just make sure that this projection will be right. So I will say Qwen3 Curie projection like that, and then I would expect it to be like that, and I also, yeah, that's good. And then what I will do is I will now do the second part where I take the Huggingface Curie projections and everything and ensure that that is right. So what do I do here? I will search for Qwen3 modeling, and then I will look at this. Qwen3 attention. Before there was, I just need to. Good. What I'm thinking about now is I need to load it. I can load the Huggingface Qwen and I can get it, but I do not have an easy way of acquiring the Curie states. And I can either copy this whole thing and set it right with everything, or I can take out the module. I can load the entire thing. I load the entire thing, but I change the module to return Q, and then I take out the module and then I will return. Yeah, so what we'll do here is I'll just return the Curie states. Well, then it might seem a bit weird, but I think it's okay. I'll return the Curie states, then I will do the thing I did up here. So I have many scripts where I load the model. So for example, like this. So actually it's just this. And then I will load the entire model. Then I will take my model, something like this, and then I will say attention 0, HF attention 0. And I will forward, what will I forward? I will forward whatever I need to forward, and this is the hidden states and some kind of position embeddings that are not being used, hopefully. Not yet, at least, because I already returned here. So I'll just say, that I need to import from part 6 T to J and J to T. Does this work? This is not what it was called. J to T B float 16. Because then I can now say that my input will be the same as here. I'll say xpt is T to J B float 16. Was that what it was called? No, just T to J. T to J of my x. There's no attribute detach. J to T. Yeah. So like that. And then I will forward that together with some non-thing. And required one attention mask. Attention mask. None. Pew. Must be attention not. It's not equal to float. Confused because M1 to have the same D type inside the linear, but HF attention 0, it has this, it has a Q projection and it has some weights, and this is a D type. What? What? The floats? Yeah, there is a reason why I'm porting it already, of course. So this is kind of weird because the model parameters are in B float, and I was very sure here, up here. Really, I shouldn't have imported it separately. I should have some kind of function for importing this because it will happen all the time. Okay, now I at least have that, and this should then be the HF the Huggingface Qwen3. Great. And then we have HF Qwen projection.shape. It is this shape, and our Qwen3 projections are this. They have some other shape, or the same shape. They have the same shape. And then we will say HF Qwen projection jax is equal to T to J of this Qwen projection. And then we will say J and P dot all close of the Qwen3 projection and the HF Qwen projection J. And we will see. Yeah, they're not the same shape. It just looked like it. So we will have to reshape it. And I think you can do that with George.einsam. So we have I2, 2, 4, 16, 2, 4, 16, 128. I forget what it is about 2 and 4. I'll just skip that for now. A, B, C, D, 2, A, C, B, D, HF Qwen projection. Does this work? I think it works. HF Qwen projection reshaped. And then we will say, are these all close? And the array or scalar are even good at class, because I took shape here. False. They're not all close. Okay. Are they somewhat close, or are they not at all close? They seem to be not at all close. Yeah. Good. So what can we do here? We'll have to go in and consider. I want to ideally use an einsum, and I would love to use the same kind of einsum as in the gamma code base, because einsums are nice. But that's gonna require some energy, so I'm gonna have to eat something and take a break.